Okay, here we go. 10.1 right angle trigonometry. Let's go ahead and copy this down. And so, trigonometry is from the Greek meaning measures of triangles. The ometry part is measures, and trig it stands for triangles. So what we have here is a right triangle, and you've seen this in geometry before. In fact, you probably should have learned this before already. This really should be a reminder. We have a right triangle here. Obviously, this angle is the right angle because it has a square here. Now, this angle right here that goes, from here to here is it's been labeled with a letter here. It's a Greek letter called theta. So get used to saying that theta. Maybe say it right now, theta. But anyways, theta is right here. It represents this angle. So with theta, you have three sides to theta. We're going to label what these are. So x is this side right here. And it's right next to theta. And that's what's called your adjacent side. So in this problem, in this diagram, x is the adjacent side. Adjacent means next to. And so this side is next to theta. Now y is opposite of theta. I don't know if you can tell, but if theta is right here, y is the side opposite of that. So that's called your opposite side. And then if you remember, all right triangles have what's called a hypotenuse. And that's the side opposite of the right angle. In this case, that's the side right here. So z is the hypotenuse. Okay, so what happens is when you have a right triangle and you think of it this way, you can develop what's called trigonometric functions. We're going to start with these three. There's actually more coming in this video, but we're going to start off with these because these are the most well-known. The first one's called sine theta. Even though I say sin, it's really sine. And you, when you call it sine theta, what you do is it's a ratio. It's a number over a number. And in this case, sine theta is always going to be the opposite over the hypotenuse. So it's the opposite over the hypotenuse. Such a key idea here. Likewise, we define the cosine theta, and we say cos, but it's really cosine. But cosine theta is the adjacent side over the hypotenuse. And tangent theta is defined as the opposite over the adjacent. So, like, for this triangle, for example, if I was to say, what's sine theta? Well, sine theta is my opposite over my hypotenuse. Now, remember how I defined it before? My opposite was y. So, it's going to be y over whatever my hypotenuse is, which we said is z. Let's go ahead and just finish this off real quick. Cosine theta, well, okay, theta's right here. Adjacent to theta is x, because I'm doing my adjacent over my hypotenuse. And my hypotenuse, again, is z. Then I have tangent theta. By the way, sorry, tangent. That's what that stands for, tan. Tangent theta is just your opposite over your adjacent. Well, with theta's right here, your opposite is y and your adjacent is x. So in this one, it's y over x. All right, let's go ahead and do this a little bit more. This is such a key idea to trigonometry. You got to practice a little bit. So right here it says find the value of the sine, cosine, and tangent functions for theta. So we're just going to go ahead and do that right now. Let's switch to different colors. So sine theta. So we just saw sine theta is your opposite over your hypotenuse. Okay, so if theta's right here, what's opposite of theta? That'd be 3. So I'm doing my opposite over my hypotenuse. Then what's the hypotenuse of this triangle? It'd be 5. So sine theta is 3 over 5. Let's do cosine theta. Cosine, we said, is adjacent over hypotenuse. So theta's right here. Adjacent to theta would be 4. Over your hypotenuse, which we know is 5. Tangent theta is your opposite over your adjacent. So opposite is 3 and adjacent is 4. So 3 over 4. Before we go on, and actually you're going to try this one, go ahead and copy this down. But while you try it, we're going to do it in class together. While you're copying that down, I'm going to talk about what's called SOHCAHTOA. 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 One way to help you remember when to do like what over what, like you know how we said sine theta is opposite over hypotenuse, and we said cosine is adjacent over hypotenuse. Well, one way people remember it is they remember SOHCAHTOA. See how I divided it into three parts? Well, the S stands for sine, the C stands for cosine, the T stands for tangent. And so what I have here is, it's a reminder saying sine is opposite over hypotenuse. See what I'm saying? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. If you can remember that, it makes remembering all this stuff that much easier. So try to remember this. SOHCAHTOA. It's okay. So and then try this one yourself, and let's see if you get it right in class. All right. Trigonometry. You can't do trigonometry without doing some word problems. So go ahead and copy this down. Don't copy down the bottom part yet, though. That's something slightly different. So this one says, finding a missing side, the skateboard ramp will have a height of 12 inches, and the angle between the ramp and ground will be 17 degrees. To the nearest inch, what will be the length L of the ramp? In most trigonometry word problems, you want to draw a picture. Make a huge note of that, please. Make a huge note that you want to draw a picture of what's going on. So we could probably imagine a skateboard ramp, and we can think of it as a triangle, right? A right triangle. So here's what the skateboard ramp probably looks like if you view it from the side. And the right angle would probably be right there. So now we got to think about what do we have here and how can we like label things into this picture that we just drew. So it says it'll have a height of 12 inches. Well, that would be this side right here. So we're going to label this 12 inches. And it says the angle between the ramp and the ground will be 17 degrees. So the ground's right here and the ramp is right here. So this is 17 degrees. It says to the nearest inch, what will be the length L of the ramp? So we want to know how long is this right here. So we're going to call that L. So that's what we're trying to find. This is where trigonometry comes into play. So in this problem, our theta value is 17 degrees. So maybe we'll make a note of ourselves. Theta is equal to 17 degrees. Now this is where we want to think, okay, I know I have two of my sides of the triangle labeled. What are these to 17 degrees? What I mean is 12 your opposite? Is it your adjacent, or is it your hypotenuse? Well, let's think. 17 degrees is right here, and this looks like it's opposite of this. So we have our opposite side, and then L. So we're down to L being either your hypotenuse or your adjacent. Well, if you look, L is directly across from your right angle, so this is your hypotenuse. So let's think about something. What trig function, sine, cosine, or tangent, uses hypotenuse and opposite as a ratio? Think for a moment. So if you thought about it, sine, S-I-N. Remember, SOHCAHTOA. One thing I encourage you guys to do is, when you're doing trig problems, probably always write this down as a reference. So if you look at sine, that has opposite over hypotenuse, and that's the two things that we have here. So what we're going to do is, we're going to write sine, and normally we put theta here, but we know what theta is. So we're going to put 17 degrees where theta normally would go. Now we're going to set it equal to the opposite over the hypotenuse, because that's what SOHCAHTOA says, opposite over hypotenuse. Well, the opposite is 12 over the hypotenuse, which we don't know, which is L. Okay, so now what we're going to have to do is we're going to have to solve for L. Now it's a little difficult to solve for L if it's down here. So one thing that people like to do is they like to put this over 1, so you have two fractions, and then they like to cross multiply. So you get L times sine 17 degrees equals 1 times 12, which is just 12. Well, to solve for L, if this is times sine 17 degrees, I'm going to have to divide by sine of 17 degrees so that those can cancel. So L is going to equal whatever this is, and this is where you're going to learn a few buttons on the calculator. Now, one thing you have to really realize, and again, you should remember this from geometry, is this is sine of 17 degrees. Your calculator has two modes. Actually, there's a few more, but two main ones that you're going to use. And I don't know if you can see it. Let me see if it will show up here. if you see that little like black character, yeah, there it is. See where it says D? D stands for degrees, and that's the mode that we need to be in. Some of your calculators might be in what's called radian mode, and I think I'll go over more of that in class. But your calculator needs to be in degree mode. I want you to make a note of that as well. Degree mode. Degree mode. Because if you're not in the right mode, you're not going to get the right answer. Okay, so what we're going to do is we're going to type in 12 divided by 17 degrees. So I'm going to hit 12. I'm going to hit the division sign. I'm going to type in sine of 17. So my sign button's right there, SIN. And it pops up ready to put something in parentheses. And you don't have to type the degree symbol in, because if it's in degree mode, it knows you're in degrees. And so that's our answer. So that's the length that we're looking for. It's set to the nearest inch, meaning the nearest whole number, no decimals. So you would round to what? 41. And the unit is inches. Okay. Go ahead and draw this picture real quick. So imagine you have a bird. I'm going to try my best bird to draw here. Actually wasn't that bad of a bird, I don't think. Don't judge me. And imagine the bird's flying here. Well, it's in the air. So you have these two dotted lines. And so you have this angle that you can make right here. You know, it's some angle. Well, when you have an angle that forms from this line down to here, this is called an angle of depression. When the angle is formed from the top going down like this, that's the angle of depression. Not sadness, that's not that kind of depression. Meaning, depressing sometimes meaning just going down. If you're going up toward the same line, this is called your angle of elevation. That one probably makes more sense because you know what elevate means. So it means that the angle is going up. This one, the angle is going down from the top. This is going up from the bottom. And we're going to see another word problem where that applies. Alright, so an example. A surveyor whose eye level is 6 feet above ground measures the angle of elevation to the top of the highest hill on a roller coaster to be 60.70 degrees. If the surveyor is standing 120 feet from the hill's base, what is the height of the hill to the nearest foot? This is nothing right here, by the way. Ignore that. So we have a trigonometry word problem here. We can tell because there's degrees, and what we're going to do is we're going to draw a picture first. And there's going to be a right angle right here. Now we have to. This one's a little tricky, and I want to show you a really tricky one here. It says a surveyor whose eye level is 6 feet above ground. So we gotta imagine the guy is like right here, and so his eyes are right here, and here he is standing. So he is 6 feet tall. This guy right here is 6 feet tall. Or at least like all the way to his eyes, I should say. So it says measure the angle of elevation. So that's this angle right here. Because it's starting at the eye level and you're going up. So it's an angle of elevation. If the surveyor is standing 120 feet from the hill's base, so that means this distance right here is 120 feet. What is the height of the hill to the nearest degree? Nearest foot. So the height would be this, so we don't know that. We'll call that x. And sorry, we forgot to label something. The angle of elevation, they actually tell us, is 60.7 degrees. So we know a few things here. So let's remember SOHCAHTOA. Think about the angle that you have, and what are these two to that angle? Or, x. Let's start with x. Is that your opposite, your adjacent, or is that your hypotenuse? Well, x is directly across, so this is your opposite. 120 feet. Well, that's right next to 60.7. Next to means adjacent. And you can verify that because, this side has to be your hypotenuse because it's across from your right angle. But we don't need to know it, but just to help you see the whole picture. So let's think about, if you have opposite and adjacent, which of these would you use? This one, tangent. So we're going to have tangent of theta, but actually we know what theta is in this problem. So it's really tangent of 60.7 degrees equals, so it's TOA, T-O-A, opposite over adjacent. So x over 120. Alright, so let's go ahead and put this over 1 and cross multiply. So on this side we have 120 times tangent of 60.7 degrees. And then 1 equals 1 times x, but that's just x. So hey, we've already solved for it, but all we have to do is take this and plug it into our calculator. So let's get your calculator out. Again, make sure you're in degree mode because you have degrees here. And one thing you can do is you can type this in one shot. And actually, no, let me not do that with you. Let's just do it one step at a time. Let's go ahead and take the tangent of 60.7. The tangent button's right here, at least on my calculator. It should be pretty easy to find on any calculator, really. So there's tangent, but then we have to multiply that by 120. So just hit times 120. And so instead of to the nearest foot, meaning, again, the nearest whole number, that 0.8 would round this up to 214. So 214 is our answer. To the nearest foot would make this the unit of feet. All right. Just got one more to show you. Go ahead and copy this down. So like I said, there's a few more trig functions, and we have to, you know how we had sine, cosine, and tangent? Well, we have what's called their opposites, or sometimes people call them your reciprocals. And so we have cosecant, secant, and cotangent. Cosecant is just the opposite of sine. It's hypotenuse. It's hypotenuse over opposite. This is your adjacent. Sorry, no, I keep messing it up. Sorry. It's your hypotenuse over your adjacent. And your cotangent is your adjacent over your opposite. I want you to think about these real quick. These are just the flipped over versions of sine, cosine, and tangent. That's actually the way I remember this. Cosecant is just it's opposite of sine. Secant is the opposite of cosine. I really should be saying opposite. I should be saying reciprocal. What I mean is secant is just cosine, but the reciprocal of it. Cotangent is really, let's just say it here, it's the reciprocal of tangent. So in this triangle right here, cosecant theta would be hypotenuse over opposite. That would be z over, what's our opposite? Y. Secant theta, well, that's hypotenuse over adjacent. Your hypotenuse is z. Your adjacent, okay, theta's right here. Next to that would be x. And then cotangent theta is adjacent over opposite. That will be x over y. And we can go back to the very first paper we did, and we can compare these. Watch. Where are we at? So remember, these are the same exact triangles right here, by the way, if you notice that. Like, look at sine. It's y over z. And look at your cosecant. It's z over y. That's what I mean, that these two are opposites of each other. Look at your cosine and look at your secant. So these two. So we said cosine was x over z. Then secant should be z over x. The opposite of tangent is cotangent. If tangent's y over x, then cotangent should be x over y, which is what we got here. Another way I remember this, by the way, and this helped me a lot when I took trigonometry, is see how sine begins with the letter S? Well, its opposite begins with the letter C. And see how cosine begins with the letter C? Its opposite begins with the letter S. And then tangent and cotangent, because they both have tangent in them, they'll just be opposite of each other. I'll try and explain that more. I know this is a lot to throw at you guys, but one last problem we want to do, and then I have a little riddle for you guys. Example, find the values of the 6 trigonometric functions for theta. So now we're going to do all 6. We're going to do sine, cosine, tangent, cosecant, secant, and cotangent. Watch how easy this is. So sine of theta, cosine theta, tangent theta. And then I'm going to go in this order here. So cosecant theta, secant theta, and cotangent theta. One thing that we were missing in this problem, though, is we have two of the sides, but we don't have the third one. We're going to have to do the Pythagorean theorem real quick. I'm going to do that in a different color here. So to find the side, this is our hypotenuse. We'll call it C. Remember the Pythagorean theorem from geometry. So we have 14 squared plus 48 squared equals C squared. Let's not waste any time. 14 squared plus 48 squared is 2,500. And to solve for C, because it's C squared, I'm going to have to take the square root of 2,500. So this side is 50. So that helps us get that side. So C equals 50. So now that we have all the sides, finding these should be no big deal. Now remember, to find sine, cosine, and tangent, let's start off with SOHCAHTOA. So sine is opposite over hypotenuse. So what's opposite of theta? That'd be 48 over the hypotenuse, which we just found to be 50. Now this fraction can reduce, and in math, you should always reduce your fractions. It looks like 2 goes in both of these, so that'd be 24 over 25. All right, cosine theta is adjacent over hypotenuse. So here's theta, adjacent to that is 14 over the hypotenuse, which is 50. Again, I think 2 goes in both of these, so 7 over 25 if you reduce the fraction. Tangent theta is opposite over adjacent, so opposite is 48, adjacent is 14. Then divide both of these by 2, because again, everything's divisible by 2 here. So we have 24 over 7. Now watch how easy it is. I don't need to sit there and actually go through all this again. Because if I know that cosecant is the opposite of sine, I just take this fraction and flip it over. And I can take the reduced one, so I don't even have to reduce again. If I know secant is the opposite of cosine, I take this fraction and I flip it over. And then same thing with tangent and cotangent, and that's it. So that's it. Sorry for the long video, but I mean, trigonometry, there's a lot to it. And then here's your riddle. Let's see if anyone can figure this out. What does this mean, I guess? That's what I'm trying to say. An opinion without 3.14159 is just an onion. What does that mean? Okay. Have a great spring break.